Hello everyone. Previously we had discussed on the balanced binary search tree conversions algorithm, right? So today we'll be discussing on the segment tree algorithm. This is one of the important algorithms, right? Segment tree algorithm. Next we'll be discussing the lazy propagation on the segment tree as well. So these two are very important, right? So basically if you're doing CP, right, so it will be very important. So just listen to this carefully. Let's get into the definition part. So what does the definition part say here? Let's see. A segment tree is a binary tree data structure, right? A segment tree is a binary tree data structure used for efficiently answering the range queries, right? A segment tree is a binary tree data structure used for efficiently answering range queries like sum, min or max over a subarray and updating the elements in an array. Right? A segment tree is a binary tree data structure used for efficiently answering the range queries like sum, min or max over a subarray and updating the elements in an array. It allows both query and update operations in big of logarithmic n time. It allows both query and update operations in big of log n time. Right. So let's go with the explanation part here. Remember this one, this is very important during the optimization. Mostly we make use of the segment tree for this itself, for the this one, what do we call that one, extreme optimization or the intense optimization, right? So that is the reason where we make use of the segment tree, or it may be Fenwick tree or the lazy propagation, this one on the segment trees, Fenwick trees and the sparse table. Mostly we make use of it for the intense optimization or the extreme optimization. So it allows both query and update operations in big of logarithmic n time. So let's move on with the explanation part here. So imagine if we have an array and we frequently need to do certain things, right? So we frequently need to find the sum of the element in the given range in the sense left comma right. So left is the starting range and the right is the ending range, right? And also suppose if we need to update the value of an element at the specific index, for the particular index we need to update the value in that case. Also yeah, these two things basically, if you want to find the sum or min max of the elements in a given range L comma R, and if we need to update the value of the element at the specific index using the segment tree, we can break the array into segments. By making use of the segment tree, what we can do here, we can break the array into segments or the intervals, right? So basically segment tree and this one Fenwick tree or the sparse table, basically they are used with the queries itself. Just remember this one, this is complete basics. So I just want to remember this one, I just want you to remember this one, that this will be used with the queries when we have been given range minimum queries, min max, when we have to find the min max, right? So when intervals are given basically, right? So in that case we'll be making use of the segment tree. Suppose if we want to find the sum of the element in a given range, or when we need to update the value of the element at the specific index, in these type of cases, in these kind of conditions, so using the segment tree will be better basically, because query and the update operations, it allows both query and the update operations on big of logarithmic n time, right? Using the segment tree we can break the array into segments or the intervals. Each node in the tree represents what it represents, information about the particular segment, nothing but example sum of that particular segment. So this helps in faster range queries. One thing is this helps in the faster range queries because we don't have to recalculate sums from the scratch, and also this helps in the efficient updates because only relevant segments are updated here, right? Only relevant this one segments are updated here. This is fine. So this is it about the segment tree. This is about the segment tree. This helps in faster range queries and the efficient updates, right? So because faster range queries, because we don't have to recalculate sums from the scratch, and efficient updates because we only need relevant segments that needs to be updated, right? So we have discussed this one. Now let's do one thing, let's start writing the, or let's start implementing the same thing, whatever we have discussed on the explanation in the form of code or algorithm by making use of the Python programming language, right? So let's go with the segment tree implementation, right? So let's build the segment tree first. So we have to build the segment tree first. I'll just go with def build tree. So I need certain parameters here, array as well as the segment. So this one index along with the left and right. accordingly with what we had discussed. Now the base case, what will be the base case here? If the segment represents a single element, suppose if we have the single element, if the particular segment represents the single element, then segment of that particular index, we will be assigning that one to the array of left, right? So I can write it in this way. See, if L equals R, then what we will do, I'll just go with segment index. So here this one, let me assign this one to the array of left, and also let me return something here, right? So we have to calculate the mid. For calculating the mid, this will be left plus right by 2, quite obviously, right? So this is the binary, right? So this, see here, a segment tree is a binary tree data structure, right? A segment tree is a binary tree data structure. So we will be going with the calculating mid, basically left plus r, left plus right by 2, right? So calculation of mid, I hope this is fine. Now let's build the left child. We will be building the left child. We have solved n number of problems already using the segment tree, fun victory, and the sparse table. So it's in the YouTube, I have solved n number of problems, like I have given contest, I have solved number of problems, even I have solved n number of problems in this thing, YouTube itself, basically. For the 15 problems, while I was this one giving the contest on the Node.js, I have solved that one in the YouTube as well. You can just check the playlist if you are doing the CP in the Node. Right now in the Java, I have solved around 15 problems as well. That also you can check, right? So 30 problems you will get, right? And in the contest, I have implemented many times segment tree, right? So this you can check. Right? So the playlist you can check Java, the problems that are solved in Java as well as the Node, whichever programming language that you are comfortable with, right? So also I have explained the algorithm and JavaScript, right? So and now we are getting this one in the now you'll get this one in the Python and Java. Again, I'm telling I practice in Java as well, because for the interview purpose and the others, this one for the competitive coding and all, I code in Java, right? So in the lead code, I do code in these two languages, basically Python and the Java. For the CP and other stuff, right? So for the system design, CP, and interview purpose, so these things I code in Java itself, I won't lie. So I will be practicing in the Java. You can just check, see the one that with the extension dot this one JAVA, right? So I can just check the Java code as well if you code in Java, right? So you'll get that one as well. So usually I explain in this one Python, right? So now let's move on with the further things. First we have to build the left child. So we have to build the left and right child. We know this one, right? First let's build the this one left child. So this one will be doing it recursively. So I'll just go with the build tree here. So what are the things we have? Array, segment. So we'll be going with a 2 into, as it is binary tree data structure, we'll be going with 2 into index plus 1, also left comma mid. So this is fine. Next let's build the right child. So this one will be array comma segment, this one 2 into index, so this one will be plus 2, and also mid plus 1, this is fine, and finally right. So final one here would be, we have to go with the internal node that stores the sum of the left and right children. So this one will be segment of index, so this one will be segment of 2 into index plus 1. Let me go with 2 into index plus 1, this is fine, plus segment of 2 into index plus 2, this is fine, man. Yep. Now let me come out of this one entirely. Now we are done with the build. We are done with the build tree. This one, what do we call? Build tree function, right? So next, let's go with a query. Let's go with a querying the sum and the range, QL comma QR, right? Querying left and querying right, QL comma QR. So let's go with a one more helper function named query here. So I'll just go with def query. So we have the parameters segment, we need particular segment, index left right, so this one querying left QL, querying, right? QR. This is fine. Now within this particular function, so if the range is represented by the node that is completely outside the query range, then we have to return 0. Basically it is related to the bounds, right? So in simple terms, so this one will be QL if it is greater than R or QR query, right? So this is less than L, then what we need to do, we have to return 0 in that case, right? So this is fine. The next step would be, if range is represented by the node that is completely inside the query range, then we have to return the segment of that particular index, right? Index of that particular segment. Sorry, I said it ulta basically, right? So this one, this has to be QL less than or equal to L and R less than or equal to QR. So then what we need to do here, so we have to return segment of this one, index of that particular segment. So this is fine, I believe, man. Now there is one more condition. This is quite confusing. So we have to go with a partial overlap case as well. So since I started this one many years back, so I started the segment tree, so I always used to get confused with the partial overlap case. So why we have to do this, why we have to, this one we have to at any cost, right? This one, just remember this one as well. So this will be, first we need to calculate mid actually. This will be left plus right by 2. This is fine. The next step would be, let me go with the left sum. This one will be, we have to recursively do it, right? So I'll just copy the same thing here. Query of segment comma 2 into index plus the same thing actually. So let me go with here, or let me, I thought copying this one and making the necessary sense. Let me type this one, 2 into index plus 1 left mid. So we are querying, right? So we have to go with query left and query right. So this is fine, man. So the next thing would be, we have to go with the right sum as well. So this one will be again query, we are recursively doing it, so let me make use of the query segment comma 2 into index. So this is also fine, plus 2 mid plus 1, this is also fine, comma R, right? So this one will be QL comma QR. So this is fine, man. The final one would be return what we have to return. So let me copy this one left sum along with the right sum. So here it is, right sum, right? So we are done with the query method or the query function as well. So first we went with the build tree function, next we went with the query function. So now basically build tree is building the tree, so we will be usually going with the query as well as the update, right? So we haven't written the function for the update. Basically what we need to do, we have to update the value at the given index, right? So that's what the update function does. I have mentioned this one early itself. So let me give here update. Again I need parameters here, array segment. So this one will be index left right, so this one will be position value. So this is fine. Now within the update, if left equals right, then what we need to do, so I'll just go with the array of position. So this one val and array of index, so this one equivalent to val, and finally let me go with return, right? So this is fine. Let's go with the mid. So this mid equals, so this one will be left plus right by 2. This is fine. So now let me go with a simple if condition. If position less than or equal to mid, so then what we will do, let's go with the update here recursively. We have to go with recursion itself, right? So this one will be segment comma 2 into index plus 1 comma left. So I'll just go with mid as well, along with the position and value. Yeah, correct, this is correct, right? So else what we need to do, so else what we need to do, so we have to update the internal node after updating the child as well. So this one, let me do one thing, let me copy this one entirely and let me come here, let me paste it over here. So this remains array, array segment. So instead of this one, this one idx index plus 1, so this one will be index plus 2, as we are dealing with the right one basically. So this one will be we are dealing with the right, so this one will be mid plus 1, we have to move right side, right? So we mid plus 1, so instead of the L we'll be going with the right R. So this remains same, position and the value remains same. This is fine. Yep. Now as I've said, we are left with only one thing, that is we have to update the internal node after updating the child. So this one segment of index, so this one will be segment of, this one has to be 2 into index plus 1, right? Also plus segment this one 2 into index plus 2. So this is fine, I believe. Now let's do one thing, let's go with the example usage of the driver code, right? So I'll just consider array, we have to consider some array. So I'll just go with 1, 3, 5, some and all the odd numbers. So I'm feeling like going with odd numbers. Let me go with 1, 3, 5, 7, 9, 11. This is fine. So n, let me assign this one to the length of the array, and segment SEG, so I'll just go with 0 into so this one will be 4 into n. This is fine. So now let's do one thing, we have to build the segment tree, man. So for building the segment tree, so I'll just go with the we have already written the function name build tree, right? So all I have to do is pass the array here, segment, so this one has to be 0, 0 to n minus 1. Simple. Let's go with the print for the this is for the basically for the interactive purpose, sorry. So I'll just go with segment tree. This is fine. Segment tree, let me give here segment, so this is fine. Next step would be, we'll be going with a query example, meaning we will be going with the sum of elements on the range 1 to 3. So this one result equals query of, let me go with segment here, this one will be 0, 0, n minus 1. This is also fine. So this one will be 1, 3, and let me go with the print. So this one will be sum in range 1, 3. So this is also fine, result, man. Yeah. So next what we'll be doing, so we have to update the example. So here when I say we have to update the example, we have to update the index 1 to the value 10. So let me go with the update here, update. So let me pass array, so this one will be segment 0, 0, n minus 1, so 1, 10. So this is fine. Let me go with the print statement here. So this is nothing but update array. Let me pass array here. This is fine, and let me go with the print statement again here, just for the interactive purpose. So after updating the segment, so I'll just give here update segment tree here. This is fine. So let me pass SEG is the variable we consider, right? So this is fine. Finally, let's query again after the update, right? So I'll just go with the result2 here, variable name. So I'll just go with a query of, let me pass here segment something like 0, 0. So this one from n minus 1, 1. Let me consider 3 or 5, 3. Let me go with the 3 here. So let me go with print this one sum and the range. So we are considering from 1 to 3, right? So this one has to be 1, 3. This is fine. After update, so this is fine, man. Yep, after update. So let me give here result2. This is fine. So we are done with the coding part, right? So we are done with the coding part. So this is it. So till here it was for the coding part. So till here basically. So we have went with three functions mainly. You can just consider this one as the template. I just make use of the template mostly while solving this one segment tree or the Fenwick tree or this one sparse table, right? So log 2 will be going with for the sparse table basically. So for this one segment tree or the Fenwick tree, usually we go with this one itself, a build tree query as well as the updation is not required in this one basically. Usually when updation is not required, we'll be going with the Fenwick tree, right? So for this one segment tree, we have written build tree query as well as the update. These methods are the functions basically, right? Usually we'll be going with this is fine. Now we have written the complete code, we have the idea on it. Let me tell you one thing. So here let me explain you this one, then let's run the code. So here we have written the build tree method or the build tree function. So this constructs the segment tree recursively. So as I've said, we are going with a recursion, right? So this constructs the build tree function, construct the segment tree recursively. So when L equals R here, if L equals R, whatever I have given here, it's a leaf node. So we are storing the array element. So internal nodes, what it does, it stores the sum of their left and right children, right? So this is fine. Next we are going with a query function, this one, def query, right? If the nodes range doesn't overlap the query range, then we'll be returning 0, this one, line number 32 and 33. So next, if it completely lies within the query, then we will return the stored value. Then we'll be returning the stored value, line number 34 and 35. Finally, otherwise we split the query to the both children and we will combine the result. So this one middle will be calculating and this one, right? Otherwise what we'll do, we'll split the query to both the children and we'll combine the result within the query. So we are done with the query, this one, what do we call function. Then we are going with the update function, right? Within the update function, what we are doing here, so we locate the element to update. First we have to locate the element to update, so that is the reason we are going with the position variable, right? So we need to locate the element to update, then we have to update, or we are updating the leaf node and we are backtracking to update all the parent nodes accordingly. That's what we are doing here. That's what we are doing here in simple terms, if condition, this one mainly, right? So I hope this part is clear, man. Again, in the update function, what we are doing, we are just locating the element to update first, then we are updating the leaf node and backtracking to update all the parent node, this one accordingly, wherever this one I have considered from 47 to 52, right? So this is nothing but from 54, this one example usage until 69, right? So this is fine. Now whenever this one I give here, so segment tree, what we have considered here basically, we have, so let me run this one, so then I can update this one, what do we call, sorry, then I can explain the output. So let me copy the entire file here, let me hit Ctrl J, so let me give Python file name .py 2 into index plus 2, it has to be line number 52. I have done mistake, so this one has to be 2 into, so this shift button doesn't work sometimes. This is fine. Let me run this one again. Again we have the error, list assignment index out of range. Which one? Line number 44. What mistake I have done here? If within the update, right? So this one, just give me a second here. What we are doing here, if left equal, oh, array of position, yeah, this is fine. Array of position I have considered. Oh, this one is not array of index, man. This one we have to consider segment of index, right? So so this one, let me keep clear screen here. Let me run this one again. Yeah, now we are getting the output. Let's check here. See, first we are getting 36 9 27 4 5 16 11 1 3 0 0 7 9. So this is quite obviously correct, right? So whatever this one we are considering, so that itself we are just displaying here. This is fine. We are going with a sum within the range 1 comma 3, right? So we are getting the output 15, and the updated array we have 1 10 5 7 9 11, and the updated segment array is 43, this one basically. 16, this one 27, 11, 5, 16, 11, we are getting this one. So updated segment tree has to be somewhere I have done something wrong, man. I don't know what I have done wrong, or yeah, this is correct as well basically, right? So I'll just explain what I have done. Sum in the range 1 comma 3, after update we are getting 22. Basically how we got this, let me explain the same. Initial segment tree, what it does, it shows the combined sum of the ranges, right? So initial this one segment tree, what it shows, basically it shows the combined sum of the ranges. So see here, we have 1 3 5 7 9 11, right? So when we sum up all the things, we get 36. Next we are going with 9, next we are going with 27. So leaving 1, so we are getting this one. The initial segment tree is nothing but it is showing the combined sum of the ranges basically, right? So this is fine, we know this one, right? So now this is fine. Sum in the range 1 2 3 15, because elements are basically 3 5 and 7, where this is yeah, so basically we are considering from 1 to 3, right? So this one, let me tell you one thing here. Yeah, this is index 0, this is index 1, and this is index 2, and this is index 3 4, and this one is 5. We are considering from 1 to 3, this one, right? So 1 2 3 is nothing but 3 5 7. When you sum up this one, what will be the output? Basically 7 plus 5 is 12, 12 plus 3 is nothing but the 15. So sum in the range 1 to 3 we are outputting basically within the example usage, where it is, yeah, sum in the range, this one, this, but line number 61 and 62. So we are getting the output 15, which is absolutely correct. We are getting the correct output, right? So updating array, so after updating the index 1 to 10, so we are updating the index 1 to 10, man. See here in updation, see here segment 0 0. So this one, let me delete this one and show you. See this one in the update, what we are doing, so we are updating index 1 to 10 basically, index 1 to 10. So now the new array becomes, see here, 1 3 5 7 1 3 5 7 9 11. We have the index 1. When we update this one, we have to get 1 10 5 7 9 11. Did we get the correct output? Yeah, we have got the correct output, 1 10 5 7 9 11. So updated segment tree, when we sum up, so this one actually what it gives, so this one itself basically, right? So 43 16 27. So it can be of the any order. If you are getting any other order basically, so that is also correct, man. Order doesn't matter, right? So this is fine, right? So now again what we are doing here in the last step, as I have said, we are querying again after the update 1 comma 3, basically from 1 comma 3. So now this is index 0. So this is index 0, this is 1 2 3 4 5, right? So this time when we query from 1 to 3, we have to get 10 plus 5 plus 7, nothing but here 10 plus index 1 10, index 2 5 plus index 3 7. So this one will be 7 plus 5 12, 12 plus 10 equals 22, right? So this one is 22. So the output that we got here is 22, right? So the output that we got here is 22, right? So the output that we got here is 22, which we are getting the desired output, right? Sum in the range 1 comma 3 after the updation is 22, right? So because we have updated the value of the index 1 from 3 to 10, right? So we are getting the output 22. So segment tree basically what it does here, it reflects the updated values efficiently without the full rebuild. That is the reason we make use of the segment tree basically. Usually we make use of it for the intense optimization, as I've said. So this is about the segment tree, what do we call, algorithm, right? So we are done with the segment tree algorithm. So this is it. We have discussed the algorithm. We have went with the definition explanation part. We have went with this one algorithm. Step by step I have explained. Then we went with the usage. Then we ran the code. We explained. So we discussed the output as well. We are getting the desired output now. As we are done with the segment tree algorithm, so I'll just summarize whatever we have learned so far. Just try to remember these 3 or 4 points, which is very important, right? So first thing here would be the segment tree. Segment tree, what it does, it stores the data for the range of an array, right? Ranges of an array. So again, segment tree stores the data for the ranges of an array. So it allows big O of logarithmic and query and big O of log and update operations. What it does, it allows, again, this is very important. So we make use of it for the intense optimization, as I've said, or as I've stressed multiple times. We use it because it allows big O of logarithmic n query and big O of logarithmic n update operations. That is the reason most of the times we make use of it for the intense optimization, right? So whenever you are implementing within the context or within the code base, so this will be the main usage. So we make use of the segment tree because it allows big O of logarithmic n query and big O of log n update operations. So this is basically ideal for the problems involving frequent range queries and the updates. So some of the common applications are range sum, range minimum, range maximum, etc. Again, range sum, range minimum, range maximum, etc. Right. So these are some of the common applications: range sum, range minimum, range maximum, etc. So now we are done with this part. Right? So we are done with the segment tree algorithm. Next, what we will be doing, we will be discussing on the topic. So we'll be, just give me a second here. Next, we'll be discussing on the topic lazy propagation and the segment tree. Lazy propagation and the segment tree. Right. So we are done with the segment tree approach. We are done with the segment tree approach. Algo. So next, as I've said, we'll be discussing lazy propagation in the segment tree algorithm. Right. So for now, this is it. Thanks for watching, guys.